Okay, class, so today we're going to talk about the basic motor control circuit, the start-stop circuit. We're going to go through each component of it. We're going to go through how it operates in relation to basic theory and in relation to print reading. As you can see here on the board, I've got a 480 feed, 480 being three phases, Alpha, Bravo, and Charlie phase, that'll be coming in from a motor control board through a circuit breaker, through the motor starter, and then essentially to the motor. So the first thing we want to look at is why we step it down to 120 volts, because here we've got a step down transformer. We come off two phases of the 480 feed. And so why do we step it down? First of all, we wouldn't have to. We could very well make the control components 480 volt control components. But if we did, number one, the cost of the components would be outrageous. The amount of space that it took up would be outrageous. And also it would be harder to troubleshoot and to work on. So for cost, for safety, for the amount of space it takes up, we typically will step it down to a low control voltage for our control part of the circuit. So starting here, we've got a control transformer. Control transformer is typically a 480 to 120 volt component, typically about the size of your fist, maybe a little bit bigger, that we use. And you'll see here that the circuit also has a fuse wired in series in the control circuit. So we'll start here. The first component is a stop button. Now a stop button is a momentary component. It's a normally closed momentary push button. And what I mean by momentary is that if you walk into a room and you flip a switch on, that switch stays in that position. You don't have to hold it there. But a stop button or a momentary push button is just the opposite. It only stays in the state that you manipulate it to as long as you sit there and hold it to that position. So if I go and I push a stop button and I release, it goes back to the shelf state or to the original state. So that's why we call it a momentary component, normally closed for the stop button. Now, the next component would be a start button. A start button is a normally open, and that's how it differs from the stop button. Stop button is normally closed. The start button is a normally open momentary push button. So if we go and we push the start button and it's a normally open momentary device, it's only going to make the contacts up as long as we keep the button held down. Here we have our control coil, and here we have our overloads. Now, you see that I got this portion of the circuit boxed in. That is the primary motor starter. Okay, so this is a relay in itself, and then this is a separate relay. These are not the same ones. And then here's our actual motor. So let's just go through the operation of the start-stop circuit. Okay, so we have 480 volts because our breaker's closed, so our transformer's hot. So we've got potential for current to flow. Normally closed contacts on the start button, remember that. So we've got potential for current to flow through here because we've got a path up until here because we have open contacts on the start button. Our M coil, our auxiliary sealing contact is open because we have yet to energize the M coil. So once we press the start button, we make a path for current to flow in the circuit. So current flows in the circuit, energizes the M coil or control coil, and we have a complete path. Now the auxiliary contacts or seal-in contacts are a part of this. This is an actual coil. So it's a coil of wire, and as current flows through a coil, we know it creates a magnetic field. Well, as that magnetic field is energized, it has a field of magnetism through it, so it actuates an armature that goes up through the coil. Well, as that armature actuates, it has a set of contacts that work with the armature. So as it is energized and it pulls the armature in, it also closes this M coil. Now when the M coil closes, what we have is an alternate path for the current to flow. So it also can flow through this path. And this is all happening at the same time as the circuit's energized. So as we release the start button, we still have a path for current to flow because this is energized, sealing itself in. So as we release the start button, we still have a complete path for current to flow. Now keep in mind this is a series circuit, and in a series circuit we have the current flowing in one direction, one way, only one path. So to stop the current flow in a series circuit, all we have to do is open a path. So that's where the stop button comes in. Normally closed contacts, and as we press the stop button, it breaks the current flow, de-energizes the control coil. As it's de-energized, current's no longer flowing, we no longer have the magnetic field, the armature actuates, opens up the seal-in contacts, and as you release the stop button, and that path is made up again, we have an open path because the auxiliary seal-in contacts are open and the start button's not depressed. So now we're sitting back just like we started. Okay, so let's say that we had hit the start button, we've got current flowing, the motor's running, and we had too much current flow due to a fault. Say something went to ground or whatever the case may be, and the fuse opened up. Well, the fuse, just like the stop button, breaks the current flow in the series circuit, de-energizes the M coil, causes the motor to stop. Now what if we wanted to add a start button or add a stop button? That's a very, very simple thing to do. A lot of people, my students in the past, have said, well, I need another control coil, I need another seal-in contact. That's not the case. You don't need either. You can add as many start buttons, you can add as many stop buttons as you want to add. The only thing is you just have to make sure they're wired right. So let's start with the start button. If we wanted to add a start button, we could add as many as we want to. We could add them in any location that we wanted to. All we have to do is to make sure that they're wired in parallel with the current start button. So if I make me a little parallel path here, I'm going to make another normally open momentary push button. So now I have two start buttons in parallel. So if I press this start button, it has the same effect. It makes a path for current to flow, energizing the M coil, actuating the seal-in contacts, and as I release this start button, I've energized the M coil, it's sealed in, so we have current flowing through the series circuit, we have the motor energized and running. Okay, and I could add 2 or 3 or 15 or 20, it doesn't matter, as long as they're all wired in parallel. Okay, now let's look at the stop button. A lot of people think, well, hey, it's the same thing with the stop button. Okay, I just add a stop button in parallel and I'm good to go. That's not the case. Let's look at what would happen if we wired a stop button in parallel with the current stop button. Okay, so I'm going to make a parallel path. Remember, we said the stop button was a normally closed momentary push button. So we're energized. We've got current flow in the control circuit. If we go and we press the stop button, now remember, since this is normally closed, we have a path through this stop button, and we also have a path through the second stop button that we've just wired in parallel. So if I press one stop button, I still have a path for the current to flow through the other one. And likewise, if I open this stop button, I still have a path to flow through this one. So if I had them wired in parallel, I would have to open both stop buttons all at the same time in order to stop the current flow in the circuit. Not what we want. So let's go back to the drawing board. Now remember, we said in a series circuit, current flows through the components. All the current flows through each component, okay? So what we want to do is we want to break the current flow. So I can add as many stop buttons as I want, as long as I wire them in series in the circuit. That way, if I press this one, it stops the current flow in the entire circuit, de-energizing the M coil, opening up the seal-in contacts, stopping the motor. Like same way here. If I open it up here, even if this one is still closed, I've broken my path through the series circuit, de-energizing the M coil, dropping the seal-in contact out, thus stopping the motor. So what we've got here, remember, is this overload is actually part of this thermal device here in the main motor starter. Now when we energize this M-coil, it does two things. Number one, it seals itself in, but this M-coil also goes to the coil on the main motor starter. So when we energize this, we're also energizing the coil on the main motor starter. Now, that's why when we drop it out and we hit the stop button, this is de-energized. We no longer have the coil energized on the main motor starter, and that's what makes the motor stop running. Now we have these thermal devices here that are essentially solder pots. They have, as current flows through a conductor, it creates heat. And in a motor starter, we have these solder pots, or thermal devices, that are set at a certain threshold. So there's a certain amount of current, whatever the threshold is. When it reaches that for a certain amount of time, then it melts the solder pots, and when the solder pots open up, it actuates this overload contact, and when this overload contact opens, it works just the same as a fuse. It works just the same as any of our stop buttons that we put in. It stops the current flow in the series circuit, de-energizes the M-coil, opens the seal in, stops the motor. Okay, so that's the start-stop circuit in a nutshell. If you have any further questions, feel free to shoot me an email, give me a call. I'll be glad to talk to you and bring you to any kind of understanding that you need. And I appreciate your time. Thank you.